This is Math 97, Quiz 3 topics. Solving for a variable in terms of other variables in a rational equation. So first they will specify which variable they want us to solve for. In the first one we have solve for c. 3 equals a over c. You notice that c is in the denominator of the fraction, and so to get it out of the denominator we need to multiply both sides by c. When we do that, we'd have 3c equals a, because multiplying by c on the right side would cancel that c in the denominator. And now we want to solve for c, and so we would divide both sides by 3. This would cancel out, and so c equals a over 3. Sometimes the hard thing for people in solving these types of problems is that you don't get something that is a single number answer. It's an expression, and that's okay. So in this case, c is equal to a over 3. Our second one says solve for t. We have n over 2 equals m over t. Whenever you have two equal fractions, you can do what's called cross multiplying. So we can say n times t equals 2 times m. The reason for this, we can think of it another way, is that we multiply by the least common denominator of all the fractions present. And so 2 and t both have to be in that denominator. So if we multiplied on the left side by 2t, and we multiplied on the right side by 2t, on the left side the 2's would cancel, leaving tn or nt. On the right side the t's would cancel, leaving m times 2 or 2m. So cross multiplying is just a quick way to do that. We're solving for t, and so divide both sides by n in order to get t alone. Those n's will cancel, and so we have t equals 2m over n, and that is our final answer. Number 3 says solve for w. Again, w is in the denominator of a fraction. Now we have a sum down there. That's okay. We can multiply both fractions by 7 plus w. Okay, and so on the right side, the 7 plus w's would cancel out, leaving us with just s. On the left side, we have 7 plus w, that quantity times r. Since we want to solve for w, let's go ahead and distribute this. So we have 7r plus wr equals s. And next, we want to subtract the 7r from both sides. So we'd have rw equals s minus 7r. Since we're still solving for w, we want to divide everything remaining by r. I divide by r here and here. And so my final step looks like this. W equals s minus 7r all over r. Okay, our fourth example says solve for little r. Again, we're multiplying by this part in the denominator, r minus 5, on both sides. And we'll go ahead and distribute that right away. So we have u minus p equals mr minus 5m. I want the r term alone, so let's add 5m to both sides. This gives me u minus p plus 5m equals mr. And so the final step is to divide both sides by m. It gives me u minus p plus 5m all over m equals r. Finally, we have solve for g. H minus 2 over g equals 6 over f. All right, here we have two different denominators, and so let's multiply every term by that least common denominator. And so we'll multiply by gf. So the first one becomes gfh minus GF times 2 over G. These G's will cancel. And then GF times the 6 over F, so the F's will cancel. So now we have GFH minus 2F equals 6G. I want to solve for G. You notice I actually have two different G terms in this problem. And so let's move this G term over to the right side so the G's are together by subtracting that. I have negative 2F equals 6G minus GFH. Okay, you might say, well, how can I get the G by itself? I have to factor it out. And so G is a common factor of these two. I can put the G in the front and have 6 minus FH inside. I still have negative 2F on the left. And then go ahead and divide by 6 minus FH on both sides so that these will cancel and my G will be alone. And so my final expression will be G is equal to negative 2F over 6 minus FH.